Hey there students, welcome to New York City, the location from which I'm making this video today. Today's video is all about exponential functions, specifically solving them. So you're going to need to be able to solve this kind of thing using technology as well as algebraically. We're going to focus on the basics of algebraically in this video. Then we'll go on to solving more technical ones or difficult ones in class, and also apply them to practical applications, which is where we'll use the class pad a little bit more as well. Okay, now here's something to start us off with. We've got a little rule here that we can use and we can apply it. What we might do is look at it in the context of this question here. So solving 2 to the power x equals 2 to the power 2. So if we have a look at that, so 2 to the power x equals 2 to the power 2, and we've got to solve that for x. So the implication here is if 2 to the power something is equal to 2 to the power 2, then that something, our value for x, is going to have to be 2. It's going to have to be the same thing. And the reason that becomes useful is that we can use that kind of relationship to solve equations. But the important part is for this kind of question, we need to make sure that the bases are the same on both sides of the equal sign for us to be able to solve it in this way. So as an example, if we said that if we had this framed slightly differently, if it was, say, 2 to the power x equals 4, intuitively we know that 2 squared equals 4. But what we've got to do as part of our working out for this sort of question is make the bases the same as one another. So your next line would be 2 to the power x equals 2 squared. And now I've got that base of 2 on both sides of the equal sign. And then I can use that relationship to help me solve it, not to the power x, to the power 2. Good catch if you spotted that at home. So now we've got it in that format, 2 to the power x equals 2 to the power something. So we can say that x is going to be equal to that something, which is 2. Okay, we've got 4 examples to do today, and then, as I say, we'll pick up some more tricky ones during class time. But this will give the idea of these videos again is that you have the base knowledge for us to just jump straight into it and have less time of your teachers talking in the classroom. So let's have a look at this one. We've got 2 to the power x is equal to 8. Now, our next line of working out has got to be, well, let's rewrite that 8 as 2 to the power something, which of course will be 2 to the power 3. And then we can say that if 2 to the power something equals 2 to the power 3, then the value of that something, our x variable, has got to be 3. Moving on to something a little bit different. So this time we've got 3 to the power x take 1 is equal to 81. Now we've got to do something kind of similar for this one. We've got to do 3 to the power x take 1. We need to get our base on the right hand side be equal to 3 because we want them to both be the same. So then we think, well, can I raise 3 to a particular power to give me 81? And the answer to that is yes, we can. So I'm going to go 3 to the power 4. 3 squared is 9, cubed is 27, and to the power 4 is 81. But now it's set up something that looks a little bit different. So we've got 3 to the power x take 1 on the left, and we've got 3 to the power 4 on the right. So what that implies is that x take 1 is going to be equal to 4. So this one isn't a straight up x equals something. We've got a, albeit pretty easy, but we have an equation to solve here. So if x take 1 is 4, then x has got to be equal to 5. So we won't always leave you with a clear-cut x equals something. There might be a little bit more work to do afterwards. Okay, let's do another one. So this one needs us to use our index laws a little bit more than the previous examples. So we've got 5 to the power 2x take 4, and that's equal to 25 to the power negative x plus 2. All right, so hopefully it's pretty clear that we need to write both of these in terms of 5 to the power of something. But what we've got to do there is say, well, let's say 5 to the power 2. We'll put that there instead of our 25. But that is being raised to the power negative x plus 2. So we actually haven't made the bases the same just yet, because on the left-hand side, we've got a base of 5, and that's been taken to the power something else. Oh, I got rid of the whole thing. I didn't want to do that. One moment, please. Oh, my high-precision pen was not so precise in the end. Let's fix that up. Okay, cool. And then on the right hand side, at the moment, we've got 5 squared as a base being raised to the power negative x plus 2. So what we've got to do is use one of our index laws to help us here. And we remember that if we raise a base to a power and then raise that to a power once again, the way that we do that is to multiply those powers together like that. So our next line of working out for this one is going to look a little bit like this. 5 to the power 2x take 4. And what I'm going to have on now on the right hand side is, well, if I multiply 2 by negative x and 2, it's kind of like an expanding bracket sort of situation. So I've got 5 to the power 2 times negative x plus 2, which if we go a little further again, we've got 5 to the power 2x take 4 is equal to 5 to the power negative 2x plus 4. Okay, so in both of those lines of working out, actually, we've got the base of 5 for both of them. So it's 5 to the power 2x take 4 equals 5 to the power negative 2x plus 4. So what we can infer from that is that 2x take 4 is going to be equal to negative 2x plus 4. Quick bit of solving for this one. Add 2x to both sides gives us 4x on the left. Adding 4 to both sides gives us 8 on the right. And then dividing is going to give us x is equal to 2. So yeah, so that's an example where we've got to make the bases the same, but also use a little bit of our index laws knowledge as well. Okay, and last but not least, we've got 3 to the power 5x take 10 is equal to 1. So at first glance, we'll look at this one and go, well, I can't make these bases the same. I can't really manipulate 1 or 3. Like 3 is a prime number. I can't like break it down in any way. But what we can do is use our 0 index property. So let's say 3 to the power 5x take 10 is equal to 1. What we can recall for this one is that anything to the power 0 is equal to 1. So let's say instead 3 to the power 5x take 10 is equal to 3 to the power 0, because that still equals 1. And now we've got the same base on the left and the right side of the equation, and we can go ahead and solve it from there. So let's go 5x take 10 is equal to 0. So 5x is going to equal 10, and finally x is going to be equal to 2. Wonderful. Okay, that's the basics that you need to know before class, and we will continue on that during your lesson. Well, say we. If you're in my class, it's we. If you're not, it's you and your teacher. Bye.